Alright, this video is to give you instruction on how to write a number in scientific notation as well as how to multiply and divide in scientific notation. And once again, please remember that you can always rewind or fast forward as needed. Alright, scientific notation. Scientific notation is really just a way of writing a really big number in a more compact form, as it's easier to write down, as well as you're a lot less likely to make a mistake. For example, if you had this number and you had to write this number out, if you were me, you'd drop a couple zeros by accident. But that number can be represented as 1.23 times 10 to the 25th. And this number are the same thing. This one's in scientific notation and this one's not. So let me say this number out loud again so you know how it's said. It's 1.23 times 10 to the 25th. Alright, so on the left side we have some rules, some steps if you will, as how to put a number in scientific notation, and on the right we have some examples. So our first number is 123,000. First off, we need to put the decimal spot after the first digit and eliminate any zeros after the last non-zero digit. So looking at this number, the decimal spot's not written, and if the decimal spot's not written, it's always at the end of the number. So we'll go ahead and add that decimal spot. So the first rule though says place the decimal spot after the first digit and eliminate any zeros after the last non-zero digit. So we need to put that decimal spot right there. That's where we want to move it to, and we are going to eliminate those zeros. Next rule, it says use the exponent above the 10, that's this guy right here, to show how many places the decimal spot moved. Alright, so let's count how many spots we moved the decimal spot. We moved it once, twice, 3 times, 4 times. We moved the decimal spot 5 times. So we are going to write this number in scientific notation as 1.23, and then the times 10 tells us how many times the decimal spot moved. And we just counted, we moved it 5 times. And we made it a positive number. So when you are moving the decimal spot left, the exponent will always be positive. The other example we have is a small number, if you will, and we'll follow the same rules. Our decimal spot's already present, so we don't need to put it in, but we are going to move it after the first digit. So we are going to move it right here, because that is the first digit, non-zero digit. And we will eliminate these zeros, so goodbye and goodbye. And we need to count how many times we move that decimal spot for our exponent up there. So we're going to move it once, twice, 3 times, and in scientific notation that gets written as 3.4, there we go, times 10 to the negative 3. And the reason it's negative is because we are taking a small number and we are moving the decimal spot right. So whenever the decimal spot moves right, the exponent is negative. When the decimal spot moves left, the exponent is positive. And that is how you write a number in scientific notation. Alright, last, we are going to learn how to do some calculations with scientific notation. And we have 2 different examples, one multiplying example and one dividing example. Looking at the first one, we're going to multiply 1.5 times 10 to the 5th times 2.0 times 10 to the 2nd. So, first step, we're going to multiply the numbers while ignoring the times 10 to the part. This is the number portion of the answer. So 1.5 times 2 is 3. And then we are going to add the exponents of the times 10 to the part. So it would be 3 times 10. 5 plus 2 is 7. So the answer is 3 times 10 to the 7th. Before we can move on, though, we need to round the answer to the proper number of significant figures. So to do that, you are going to count how many significant poor figures are in this portion of the number. You do not look at the times 10 to the exponent to count significant figures. It's purely just the number portion of the scientific notation. So right here we have 2 significant figures, and right here we have 2 significant figures. So we need to write our answer in a way that has 2 significant figures. We don't look at the exponent to count significant figures, we just look at this portion. This has 1 significant figure, so when you write down your answer, you actually need to write 3.0 times 10 to the 7th. Alright, dividing with significant figures is somewhat similar to multiplying, however you're dividing. We have 4.0 times 10 to the 10 divided by 2.0 times 10 to the 8th. So we are going to divide the number portion. So we have 4 divided by 2 is simply 2. And then instead of adding the exponents when we are multiplying, we are going to subtract the exponents when you are dividing. So 10 minus 8, that's 10 minus 8 is 2. So your answer is going to be 2.0 times 10 to the 2, because we subtracted the exponents when we divided. And as far as significant figures go, this number has 2 and this number has 2 significant figures. So I've already written my answer in a form with 2 significant figures. So the answer would be 2.0 times 10 to the 2. And that's multiplying and dividing with significant figures.